Just when everyone thought GPT-4, Claude, and Gemini were unbeatable, a new AI model quietly appeared and left them all in the dust. It's called Mercury, and it's not just fast, it's rewriting the rules of how code generation works. Built by a stealth startup called Inception Labs, Mercury uses a diffusion-based architecture that doesn't even generate code left to right like traditional LLMs. The result? Blazing speeds of over 1,000 tokens per second and performance that rivals the best in the world. You're about to see why this model could shake the entire AI industry. The AI model we're talking about today is called Mercury, and it doesn't follow the rules other models like GPT-4, Claude, or Gemini are built on. While most large language models generate text token by token from left to right, Mercury throws that playbook out the window. It uses a diffusion-based architecture, a completely different way of building sequences. Instead of predicting the next token, Mercury starts with a noisy blank slate and gradually refines the entire output all at once, like cleaning up a blurry image until it becomes crystal clear. This approach comes from image generation models like Stable Diffusion, but Inception Labs has applied it to code generation, and the result is stunning. By diffusing code structure holistically instead of generating line by line, Mercury avoids common issues like early commitment to poor token paths, hallucinations, or misaligned syntax trees. It's not just theoretical innovation, it's performance you can feel. Mercury can generate code at speeds over 1,000 tokens per second, drastically faster than even Gemini Flash or Claude 3.5 Sonnet. And it maintains near-SOTA accuracy in major coding benchmarks like HumanEval and MBPP. This is more than a faster model, it's a new way of thinking about how machines can write software. While architecture sets Mercury apart, its true power shows when put to the test. In hands-on evaluations, it doesn't just keep up with top-tier competition, it outpaces them in both velocity and efficiency. Mercury completed code generation tasks like building a tic-tac-toe game, creating a Google search clone, and implementing a Sudoku solver in a matter of seconds, often rendering full functions before competitors even returned a partial output. It didn't rely on autocomplete tricks or cached responses either. These were live, adaptive outputs generated from fresh prompts. What's more impressive is its token throughput. Mercury has been clocked at over 1,000 tokens per second, making it more than twice as fast as Claude 3.5 Sonnet and significantly faster than GPT-4 Turbo. Even Gemini Flash, known for its speed, lags behind Mercury when generating complex multi-line code with nested logic and multiple components. In terms of coding benchmarks, Mercury scored a 79.5% pass rate on HumanEval, a test suite originally designed to measure code reliability and logic accuracy. On MBPP, it posted a 77.1% completion rate, ranking near top of class despite using a radically different underlying mechanism. What makes these numbers so critical is they were achieved without sacrificing reasoning or structural correctness. Mercury handled class hierarchies, recursive algorithms, and variable scope with minimal error, often improving upon flawed user input instead of echoing it. The implication? Mercury doesn't just work. It solves problems faster, cleaner, and smarter, all while operating on an engine no other model is using right now. In short, this isn't just a model that's fast, it's one that finishes first without missing steps. Mercury isn't just another entrant into the coding model race, it's a signal that the entire landscape is about to shift. Inception Labs, the minds behind this innovation, didn't just build a fast model, they redefined how machine intelligence tackles structured generation tasks. And that matters far beyond a few benchmarks. Their core philosophy centers on building models that can reason spatially, not just linearly. Traditional autoregressive systems struggle when juggling multiple context threads, especially across dispersed scopes in long-form code. Mercury, with its diffusion framework, avoids that by starting globally and resolving granular structure later, top-down thinking rather than piece-by-piece assembly. That's why Mercury can cleanly construct deeply nested architectures, multifunction pipelines, or state-driven UI logic, all while maintaining harmony between dependencies. In practice, this means fewer bugs, tighter cohesion, and near-zero syntactical confusion. Developers watching their demos didn't just see working code, They saw polished, production-ready blueprints emerge with zero iteration. But Inception Labs isn't stopping here. Their roadmap includes real-time collaborative generation, where multiple agents simulate pair programming without interrupting your flow. Think AI co-pilots that anticipate your architectural vision and offer cross-file refactors in one sweep. They're also targeting multimodal inputs, like visual wireframes that generate HTML, CSS, JS stacks on command. And perhaps most notably, they're preparing Mercury for edge deployment, stripping out latency and offering powerful on-device generation without cloud dependence. That's huge for developers building secure or offline-first applications. In terms of positioning, Inception isn't trying to compete directly with OpenAI or Anthropic on chat models. They're aiming to own the domain of code-first intelligence. The engineers behind Mercury believe programming shouldn't just be faster, it should be fundamentally more intelligent. Their model doesn't just mimic what's been done, it intuits what comes next, like a teammate who already understands the plan before you finish explaining it. For software engineers, founders, and toolmakers, Mercury represents a new category. Not a chatbot, not a search engine, but a zero-delay, context-aware builder that speaks code natively and thinks before it types. The AI future just took a sharp turn, and most of the world hasn't caught up yet. So let's step back for a second. In a world obsessed with GPT-4, Claude, and Gemini, a silent disruptor named Mercury has arrived. And it didn't just catch up, it blew past them. Built by a small, stealthy team at Inception Labs, this model doesn't use the same methods, doesn't play by the same rules, and yet delivers code that's faster, cleaner, and smarter than anything we've seen from the giants. It's not just about speed. Mercury's diffusion approach signals something bigger, a total rethink of how AI should operate when building software. It doesn't write line by line, it strategizes, restructures, and outputs entire systems in one fluid motion. And the craziest part? Most people have no idea this exists. That's what makes this moment exciting and dangerous. While the industry debates prompt injection and API pricing, Mercury is out here building apps in seconds, optimizing logic, and preparing to run on device without cloud delays. For developers, this is a wake-up call. The game isn't about who can write code faster, it's about who can think like a system. And right now, Mercury might be the first model that actually does. 100% of you watching, drop a comment. Does Mercury excite you, scare you, or both? Could this reshape the dev world overnight? We're reading every single reply. If this blew your mind even a little, like, subscribe, and turn on notifications because the AI race is heating up and the next wave is already here.